Okay, so you now have done an example using mutually coupled inductors, and you might just have a question. Well, this term mutual inductance M, where does that even come from? What's the purpose of it? So I don't want to get too much into the physics of induction and the physics of mutual coupling, but basically the situation is this. We've got a coil, and we've got a second coil. And there's two things that govern these coils, magnetic interaction with one another. When a current flows in this guy, what happens, as we know, is a magnetic field is created that surrounds this. And the coupling between L1 and L2 is based on how much of this magnetic field permeates through L2. The two things that really govern that from a physical perspective are the distance between the two coils, and then also if the coils happen to be connected using any sort of magnetic material. So very commonly what will occur is that you've got some sort of magnetic core, and the coils are physically wound around this core. Right? Not very good coils, but I think you get the point. And so what is this magnetic material composed of? What's its magnetic permeability? And what is the distance separating those two coils? And that's what governs how much M there is. And M comes from a formula. It comes from M, the mutual inductance, is equal to K times the square root of L1 times L2, where L1 and L2 are the self-inductance of the primary, or the coils, of the two inductors in the coil, in essence. K is called the coefficient of coupling, so K is called the coefficient of coupling. And it has to be in the range, whoops, sorry about that. 0 is less than or equal to K, is less than or equal to 1. And basically what is happening is that if K is 0, there is no magnetic coupling between the two. The magnetic field established in L1 in no way affects L2, and if K is 1, basically all the magnetic coupling from 1 influences 2. So basically K is a multiplier that tells us what the geometric mean of the two inductors are there. So that's just kind of a little tidbit about where does the K value, or where does the mutual inductance come from. So basically the condition is that M tells us how much of the magnetic flux from coil 1 is linked into coil 2. If this material is a high quality magnetic material such as iron, cobalt, or nickel, and these coils are closely connected together, this creates a space with high magnetic permeance, and we'll have a coefficient of coupling that approaches unity. If this is a non-magnetic material, and this is a big space, there is very little coefficient of coupling. That would give you a value of K of about 0. In power systems, we want coefficients of couplings in 1. Communication systems, on the other hand, especially things like RFID that use inductive coupling technologies, those will have lower coefficients of couplings closer to 0.